Here's one more algorithm looking at processing a two-dimensional array. What we have here are kind of like parallel arrays. We have a two-dimensional array, again matrix with 3 rows and 4 columns. And now we also have a one-dimensional array called totals with 3 rows. And there's going to be a correspondence between the rows here and the row in total, because what we're going to do is we're going to sum the values in each row and hold that sum in the total array. So we're going to have our row and column integer variables that will act like subscripts to matrix. Row will also be a subscript for totals. And then we're going to have an accumulator called sum, and that sum will hold the total of that row. However, once we're done with that row, and recall how we process two-dimensional arrays, you go down to the next row. I don't want to hold this sum, so every time I come down to the next row, I got to reset sum to 0 so that I'm only adding this row. If I forget to reset sum to 0, what I'll end up doing is having the total of this row and the total of this row into here, and that's not what I want. So we're going to initialize row here to 0, and normal process of a two-dimensional array. And I am at the beginning of a row. So as I'm at the beginning of a row, I'm thinking I need an accumulator for this row. This is when I'm going to set sum to 0. Okay, we go into the next loop and set column to 0. And we're going to then add to sum whatever's already in sum plus matrix at 0, 0. So sum becomes 19. And we end this loop and loop back up there and increment column to 1. And again, we're going to add 19 to matrix at 0, 1, which is 21. And that happens to be 40. I might have set this up to make it easier for me. Oops, 40. Okay. So we have 40, and we loop back up, and column becomes 2. And we will then add 40 to whatever is at matrix at 0, 2. And 40 and 16 will be 56. And then we'll loop back up. Column becomes 3. And we'll add matrix at 0, 3, which is 44 to 56, giving us 100. And we'll loop back up, making that 4, and we exit the loop. So because we exceed the 3, that puts us down here. Hey, we've already totaled that row. It's time for us to take that sum and put it at totals at row, row being 0, so 100 in here. Okay, we hit the N4 and loop back up to this outer loop and set rows to 1. After setting rows to 1, coming down, and notice that, hey, sum gets initialized again. It's exactly what we wanted to do. So erase all these old values here and put sum back down to 0 again. And what happens to column? Okay, got to erase those values too. And we start all over again. And column will become 0. And, okay, so we're going to go to sum, which is 0, and then matrix at 1, 0, which is 50. So sum will become 50. And we loop back up, and we're looping here, and column gets incremented. And matrix at 1, 1 is 20. 20 and 50 will be 70. And we'll loop back up. Column becomes 2. And matrix at 1, 2 is 10. 10 and 70 will be 80. And we'll loop back up. Column becomes 3. And we'll add matrix at 1, 3, which was 15, and we'll have a 95 here. Okay, and so then we'll loop back up. 4 exits the loop. Then we set totals at 1 to sum, so 95 goes here. And the logic continues until you finish processing the array.